4.3, we're going to continue to find the derivatives of things, but we're going to introduce a couple properties that can help us find the derivatives. So if we're multiplying two things together or dividing, we've got the product rule and the quotient rule to help us find the derivative. So in example 1, it says, is it true or false that we can take the derivative of f times g and get the same answer as the derivative of f times the derivative of g? Well, let's find out if it gives us the same thing. So first, let's find the derivative of f times g. So it gives us f and g. So when we multiply these two together, what do we get? X to the 5th. Awesome. So we have x to the 5th power. What would the derivative of x to the 5th power be? 5x to the 4th. Perfect. That's what we did last week. So 5x to the 4th. Now let's see if we get the same thing where we take the derivative of f and the derivative of g and multiply them together. So the derivative of f would be what? 2x, perfect. And the derivative of g would be what? 3x squared, awesome. And if we multiply these two answers together, what do we get? 6x cubed. Did we get the same thing? No. So this is not true. So you can't just take the derivative separate and hope you get the same answer. It does not work this way. So when we have two terms that we're multiplying to each other, we use the product rule. So the product rule is we take the first term, multiply it by the derivative of the second, plus the second term times the derivative of the first. So if we have two functions that are being multiplied together, this is what we would do to take the derivative. The first times the derivative of the second, plus the second times the derivative of the first. Now it is possible that we could have three terms. There's a question like this in the homework. I'll give you a heads up if there's going to be one like this on the quiz, but I've actually never seen this formula before, but it's good practice. But I'll let you know if you have to memorize this one. So it'll be the derivative of the first times the second and the third, plus the derivative of the second times the first times the third, plus the derivative of the third times the first times the second. This one you have to memorize. The second one, I'll let you know if you need to know for the quiz coming up. But there is a question like that on the homework. Any questions here? All right, let's do example 3. So here we're going to use the product rule. This should say product. So here it gives us g of x equals x squared plus 1 times f of x. But it doesn't tell us what exactly f of x is. It does give us values for f of x. This is going to be our first term. F of x is going to be the second. So we're going to use our products rule. The first, which I'll just call, it's kind of hard here when it gives you an f of x and it's not actually f of x, but I'll write it for us. The first times the derivative of the second plus the second times the derivative of the first. So our first term is x squared plus 1 times the derivative of the second. Well, second is just f of x, so the derivative of that would be f prime of x is equal to, plus the second, which is f of x, times the derivative of the first. What's the derivative of x squared plus 1? 2x. Awesome. So this is g prime of x, our derivative, but it asks us to find the derivative of, to plug in 2 into our derivative, so g prime of 2. So let's plug 2 into all of our x's. We have 2 squared plus 1 times f prime of 2 plus f of 2 plus 2 times, or times 2 times 2. What is f prime of 2? -1. It tells us that right here. So I'm going to replace the f prime of 2 with -1. What is f of 2? 3. It tells us that here. So I'm going to replace f of 2 with 3. From here, we're just going to do the math. 2 squared would be 4 plus 1 is 5. So we have 5 times -1 would be -5. Plus 3 times 2 times 2 would be 4. So 3 times 4 is 12. So g prime of 2 would be what? 7. Awesome. Next, we have the quotient rule. So the quotient rule's got a little bit more going on than the product rule, but it's not really an acronym, but one way to remember is if f of x is on top and g of x is on the bottom, our denominator, it's going to be low, so whatever your denominator is, times the derivative of what's up top, so low d high minus high, so what's up top, times the derivative of the bottom. So low d high minus high d low over low squared. It's supposed to be like a song, I think. Low d high minus high d low over low squared. We'll do an example. I'll find a YouTube video for you guys if it plays a song, something that'll get stuck in your head so we can remember. All right, so let's look at A. So low d high minus high d low. So you already remember. Over low squared. Don't forget the denominator. So low is going to be what's down low, so the denominator. So that would be x squared plus 1 times the derivative of what's up high. So d high stands for the derivative of what's up high. What's the derivative of 5x minus 2? 5. Perfect. Minus high, so that's what's up high, 5x minus 2, times the derivative of what's down low. So d low is the derivative of the bottom. What's the derivative of x squared plus 1? 2x. Over low squared. So our denominator squared. X squared plus 1 squared. Now, when you do the quotient rule, you're starting with a fraction. Your formula is a fraction. Most of the time, your answer is going to be a fraction unless it simplifies out. But most of the time, your answer will be a fraction also. You don't have to FOIL out the bottom. You just leave it as x squared plus 1 squared. That's fine. But we do have to simplify the top. So up top, I want to distribute the 5. So we get 5x squared plus 5 minus, be careful because we have a minus in the middle, so just be careful with the signs. I'm going to distribute the 2x here, so that would be 10x squared minus 4x, but then I have to distribute the negative. You can do both steps at the same time, just be careful with the minus. So 5x squared plus 5 minus 10x squared plus 4x. Lastly, let's combine our like terms. So minus 5x squared plus 4x plus 5 over low squared, which is x squared plus 1 squared. So this is our derivative. No. So if we FOILed this out, it would be 2x squared plus 1. But what cancels?
No. That's not what I was saying.
But the top doesn't factor. If it factored into x squared plus 1, sure, cancel it out. But it doesn't here. Does that make sense? Okay. All right, let's look at B. So same thing here. Low d high minus high d low over low squared. So low, our denominator, is 2x plus 5 times the derivative of our numerator. So d high is the derivative of what's up high. What's the derivative of x to the third power minus 3x squared minus 5? 3x squared minus 6x, perfect. Minus high, which is x cubed minus 3x squared minus 5, times the derivative of what's down low. What's the derivative of our denominator? 2. Over low squared. So 2x plus 5 squared. So when we simplify our numerator, I have to FOIL these together. So we get 6x cubed minus 12x squared plus 15x squared minus 30x. I'm going to distribute the 2, but at the same time, I'm going to distribute the negative. So I'm going to do 2 steps in one. Just be careful with the negative. Yes. All right, so then negative 2x cubed plus 6x squared plus 10. I'm going to combine my like terms. So 4x cubed. Then we have our x squareds would be 9x squared minus 30x plus 10 over 2x plus 5 squared. This would be our derivative. All right, we're also going to be finding higher order derivatives. So when you take the derivative one time, which is what we're doing, that's the first derivative. But we can take our answer and take the derivative again of that. That would be the second derivative. What we did in the last section, the first derivative, we found velocity. Or we found the slope. Second derivative is acceleration. I probably spelled it wrong, but acceleration. So to find acceleration, you take the second derivative. So there's a question at the end of the homework that asks for acceleration. You just want to take the derivative twice. So example 5 says find the derivative until it's equal to 0. So let's find our first derivative, f prime of x. What would our derivative be? Bless you. 28x cubed minus 9x squared minus 10x plus 9. Perfect. What's our second derivative? $84 x squared minus 18x minus 10. Perfect. Let's find our third derivative. So f prime prime. 3 of them. 168. What? X minus 18. Awesome. After the third derivative, you can just number it. So f4. So our fourth derivative would be what? 168. Awesome. And what about our fifth derivative? Would be 0. What would our sixth derivative be? 0. The derivative of 0 would be 0. All right, so there's a homework question. It says, find the point at which the graph has a horizontal tangent line. I'm going to write it for you. Find the point at which the graph has a horizontal tangent line of 3x squared over x squared plus 6. So this kind of involves 4.1 and 4.3. How would we find a tangent line to our graph? So we're going to take the derivative to find the tangent line. If it's a horizontal tangent line, what is our slope of a horizontal line? 0. So we're going to take the derivative and we're going to find when our derivative equals 0. So let's take our derivative first. We have to use the quotient rule. What's the quotient rule? What's the little song? Low D high. Low D high minus high D low over low squared. So low is x squared plus 6 times the derivative of the high. What's the derivative of 3x squared? 6x, perfect. Minus high, so 3x squared, times the derivative of the low. What's the derivative of x squared plus 6? 2x, awesome. Over low squared. So x squared plus 6 squared. Let's simplify our numerator. I'm going to distribute here. So 6x cubed plus 36x minus 6x cubed. Anything else simplify? Six x cubes cancel. So 36x over x squared plus 6 squared. So we want to find when this equals 0. How would we solve for x? No. We can multiply the denominator. When we multiply the denominator to 0, what do we get? 0. So 36x equals 0. So really, we just needed to set the numerator equal to 0. So what does x equal?
0.
Good job. Divide by 36. X equals 0. So it asks for what point? For which? Find the point at which the graph has a horizontal tangent line. Our x value is 0. How would we find the y? Plug it in. So I'm going to plug it into the x in my derivative here. So we have 36 times 0 over 0 squared plus 6 squared. What's the answer? 0. Awesome. So our point would be 0, 0. Any questions? All right, work on the homework. Ask questions if you have questions. Quiz is Thursday.